Welcome to our safety video discussing laser alignment. We will use this optical table with a low power class 3 laser to illustrate the proper techniques for aligning laser optics. We would use the same techniques and precautions when working with a class 4 laser. The application would be a little trickier, especially when the beam is invisible, but the principles are the same. Our goal is to align the laser so that it enters our optical components with the proper orientation. The components we will use are a periscope, two mirrors, and two irises. We will also use beam blocks to control the beam path. Before we start the alignment, let's learn how they are adjusted. Let's start with the mirror. First, find the pivot point on the rear. The knob that forms a horizontal line with the pivot point changes the horizontal tilt of the mirror. The knob that has a vertical line changes the vertical tilt of the mirror. The periscope is used to change the horizontal plane of the beam. It requires extra caution as the beam is tilted upward. The two mirrors of the periscope are aligned to ensure that the beam leaving it is parallel to the table. Irises limit the diameter of the beam. The diameter is adjusted with the knob. Be careful of reflections from the edges if the beam clips the diaphragm edges. As we adjust the components, we must take care that the open beam is never angled upward, even at a slight angle. There are many other components that might be needed for an experiment, but we would align them following the same principles. What must we do first before we turn on the laser? Select the appropriate laser eyewear. Read the label on the glasses and select a pair that covers the wavelength and has sufficient optical density. The appropriate laser safety eyewear will completely block the beam from your vision. To see the beam during alignment, use a laser viewing card. This card fluoresces at a different wavelength that will be visible through your eyewear. Be aware that some viewing cards have a reflective coating. If held at an upward angle, it could reflect the beam into your eyes. For this reason, make it a habit to always angle the viewing card down when inserting it into the beam. Remove all jewelry from your hands and arms. If you cannot remove an item, cover it by wearing disposable gloves. We will need to clean up the table. Remove any items that aren't required to be there. If possible, ask people who aren't involved in the alignment to leave the room. If they can't leave, protect them by providing eye protection or putting up a barrier. Activate the warning mechanism at the door to warn people not to enter. The next step is to block the beam at the aperture. You can't really tell how well the components are aligned, and any misalignment could send the beam across the room. Let's fire the laser. You can see the beam on the viewing card. If using a powerful laser, decrease the power as much as possible, for example, by using a neutral density filter. Now slowly move the card away from the laser while keeping the beam in the center of the card. It's important to keep control of the laser at all points during alignment. As you can see, if you lose control of the beam, this can easily result in multiple beams leaving the table. This can be a potential hazard to users' eyes, or if the laser is powerful enough, can be a potential fire hazard. For this reason, use a portable beam block to block the beam downstream from the component that is being aligned. That means block the beam just after it leaves the component. This beam block can be useful for aligning since it includes a 1/4-inch square grid. You can use the markings on the beam block as a target for aligning your optics. This is particularly helpful for making the beam parallel with the optical table, for example. There are many other designs of beam blocks. Some of them do a better job of trapping all possible reflections. You can also use different types of targets within optics for alignment. This is useful for aligning a beam to the center of the lens, for example. The flat surface of the target is a bit easier to work with, and you don't have to estimate where the center of the optic is. Another helpful tool for laser alignment is a small fiber optic camera. This is an image of a laser spot on a target. You can see the camera is able to monitor the position of the beam on a target as the optic is aligned. This can be particularly useful on a larger table with longer optical trains. A camera like this one can also be moved around the table and used on multiple optics. Here is an example of a beam being aligned through the center of an iris. Let's move on to the next component. Again, before releasing the beam, move the beam block downstream. Hold the card close to the component, but make sure the card never touches the optics. Move the card along the actual beam path and not the expected path. Make sure to never put your arm into the beam path. With a class 4 laser, this could injure you and send the beam in an unexpected path. Make it a habit to always approach a component on the optical table from the outside. Never reach across an optical table. An additional hazard that can be present during laser alignment is posed by back reflections. Some optics, in addition to transmitting light through them, will reflect some of the light back toward the laser. It's important to recognize when back reflections are occurring and adjust optics to either eliminate them or send them to a beam dump. Some optics have the explicit purpose of generating multiple beams from one incident beam. For example, a beam splitter and a set of mirrors can be used to construct an interferometer. Half of the incident beam is sent to a fixed mirror, while the other half is sent to a movable mirror. When the path length of the beam changes, interference patterns are generated. You can see those here. Diffraction gratings also generate multiple beams from one incident beam. There are two main types of diffraction gratings: reflective and transmissive. You can see with this reflective diffraction grating that additional beams are generated at various points. With transmissive gratings, the same effect happens, but after the laser passes through the optic. You can see multiple laser spots in this card, separated at regular intervals, that are resulting from the laser being incident on this transmission grating. A prism, depending on its structure and geometry, will also generate additional beams. However, unlike a diffraction grating, these beams are not spaced at regular intervals. Great care should be taken when aligning beams into these types of optics, and beam blocks should be used liberally for safety. When aligning lasers or working with a laser setup, you should avoid positioning your eyes at the same level as the beam. Don't crouch to view the beam better, and don't sit next to the table in a chair that brings your eyes close to the level of the beam. This video described the basic steps for how to align a laser beam along an optical path. You should practice the techniques on a low power setup before working with high power or invisible systems. If you have any questions about laser safety, don't hesitate to contact the Division of Research Safety at drs.illinois.edu. Thank you for your attention, and be safe out there.